Alright, so today's objective, today's lesson, is actually pretty similar to what we did in Unit 1. You guys are going to be performing function operations, which means you will be adding, you will be subtracting, multiplying, and dividing functions. So, here you go. The only thing that's really new in this is that you will be dividing functions, which allows us to then talk about restricted values on the domain. Alright, so if you turn to page 79, we're going to go through example 1. If you could pause the screen and actually split up this screen, we're going to add and subtract the function, even though the problem is asking us just to add. All right. Okay, so we're going to let f of x equal x squared minus 3x plus 4, and we're going to let g of x equal x squared plus 6x minus 3. We are going to build a new function for which we're going to add f of x and g of x. The reason we write it like this is because we want a shortcut. We don't want to say f of x plus g of x, and we just combine them to say f plus g of x. And we're actually going to subtract these as well. So why don't you go ahead and write down what I'm writing, and then we're going to have you pause it. So we're going to say that our new function is h of x is equal to my f of x, so x squared minus 3x plus 4. We need to make sure we put parentheses around that, showing that that's my f of x function, and then we are going to add x squared plus 6x minus 3. So you guys should be able to do that. Go ahead and pause this video and then check to see if your answer is correct. So combining like terms, x squared and x squared makes 2x squared. Negative 3x and positive 6x makes positive 3x. And then positive 4 and negative 3 makes positive 1. So that means that our new function h of x is equal to 2x squared plus 3x plus 1. Alright, so now we're going to subtract our function. And we're going to say that our new function h of x is equal to our f of x function, x squared minus 3x plus 4, parentheses to show that that's your new function, and minus our g of x function, so minus x squared plus 6x minus 3. Be very careful that you actually put parentheses around this, because when we are subtracting, we need to make sure that we distribute this negative right here to that function. So go ahead, pause the video, see if you can do this on your own, and then check back with me. So my new function, h of x is equal to, I can drop the parentheses, x squared minus 3x plus 4. I'm going to distribute that negative, so that means that everything in here becomes opposite of what it was. So I now have a negative x squared, a negative 6x, and now a positive 3. Okay, I go through, I combine my like terms. I find out that my new function h of x is equal to, these cancel, I get negative 9x, positive 4 and positive 3 makes positive 7. Okay, so let's move on. Example 2 says that we're going to build a new function, h of x, for which h of x is equal to f times g of x. So we're going to multiply our functions. That's what that circle means. Alright, so let's set that up. We're going to say our new function, h of x, is equal to 3x plus 4 times 5x minus 2. Make sure you put parentheses around both those functions. Here's your f of x function, here's your g of x function. Go ahead and pause the video, see if you can get this answer on your own before seeing what I got. So my new function is equal to 15x squared minus 6x plus 20x and minus 8. Combining my like terms, I find out that my new function h of x is equal to 15x squared plus 14x and minus 8. Alright, so just to review from what we did in Unit 1. Alright, go to page 78, go ahead and write this down, and then unpause the video and we'll go through it together. So this part is new from what you guys did in the first unit. We never divided a function. So we're going to go ahead and we're going to stick with what we did before. We're going to say that our new function h of x is equal to, notice that our f of x function is on top and our g of x function is on bottom or in the denominator. So order matters. We're going to keep that f of x function in the numerator. And then we are going to divide this function by our g of x. And because you guys do not know how to simplify this numerator, we haven't taught you that yet. This is done. This is what you would have for the division. So you really don't need to do much. Just place the numerator and denominator correctly for your functions. The only thing that we need to make sure that we do is we discuss restrictions. Remember that you can have any number in your numerator, negative, positive, decimal, fraction, 0. The only thing that you cannot have in your denominator is a value of 0. You cannot divide anything by 0. So with that being said, we want to know what value is going to give us a value of 0 in our denominator. So we can take our denominator and we set it equal to 0, and we find out that when x is negative 3, that negative 3 plus 3 is 0, and that will give us something that we cannot do. So what we say then is the restriction on our domain is that x cannot equal negative 3. So our domain is that x cannot equal negative 3, because when that happens, we get an error in our calculator. We cannot divide a function by negative 3. So here's your domain, and here's your h of x function. All right, so now you guys try. If you turn to page 80, example 3 is going to ask you to do the same thing. You have an f of x function, you have a g of x function, and we want to divide. So go ahead and see if you can do that on your own. Okay. So we're going to say that our new function, h of x, is equal to, again, I want to make sure that that f of x function is on top. So 3x squared plus 13x minus 10. And my g of x function is in the denominator of x plus 5. So there's my h of x function. I've shown that I've done division, and that's as far as I can go. The only other thing that I need to talk about is the domain. So the domain is what you can plug in. The only thing that I cannot have happen is I cannot have my denominator of x plus 5 equals 0. If I solve, I find out that if x is negative 5, this denominator here will give me a value of 0, which cannot happen. So my domain restriction is that x cannot equal 0. So here's my domain restriction, and then here is my h of x function. So there you go. All right, so let's look at example 4. This is kind of a review from what we've been doing the last couple of days. You may want to pause the video right now and draw in this rectangle that I have drawn. So you can go through and read the problem as well. I'll just kind of skip through where we actually talk about it. The important thing here is that you have a rug in the center of the lobby, and then this outside rectangle represents the actual lobby. It says that the dimensions of the lobby are such that one set of walls is twice the length of the other set of walls. So given the way that this rectangle is drawn, I'm going to say that this is x, and twice the length of that means that this is 2x. So this is x, and down here is also 2x. Okay. In the middle of the paragraph here, it says, with each edge of the rectangle exactly 3 feet from each wall. So this rug is exactly 3 feet from the wall. So that means this distance right here is 3 feet. This distance right here is 3 feet as well. And all the way around, we have a distance of 3 feet that the rug is from the lobby walls. All right, the question says, what is the function in terms of x that describes the area of the lobby? The lobby is this big rectangle right here that we want to find the area of. So the area of the lobby, area of lobby is equal to a side length of x times the side length of 2x, which means that area of the lobby is 2x squared, and we're talking about feet, so 2x squared square feet. So there's the area of your lobby. The next question says, what is the function in terms of x that describes the area of the rug? Well, the rug is the center rectangle, so we need to find the length and the width of that rectangle. So we know that the entire length from here to here is 2x, but this is actually shorter. So in order to get this length, we need to take that length of 2x, and we need to subtract this length of 3, and this length of 3. So that means that we're going to have 2x minus a length of 3 minus a length of 3. So that length is actually 2x minus 6. And then if I look at my other length of the rug, that would be this length. So we know that this entire length is x, and I need to take away this length of 3 and this length of 3, which means this simplifies to x minus 6. So I now have my length and my width, or vice versa. So that means that the area of my rug is equal to a side length of 2x minus 6 and a side length of x minus 6. If you multiply that out, you get 2x squared minus 12x minus 6x and plus 36. Simplified, you get that the area of the rug is 2x squared minus 18x plus 36. And this entire expression is square feet. Make sure you put parentheses around that expression. Alright, so we now have the area of the lobby, we now have the area of the rug, and we want to know what is the function that describes the area of the lobby left uncovered by the rug. So that would be this area right in here, which means we want to take our larger rectangle and we want to subtract the smaller rectangle, and we get that shaded in area. So why don't you guys go ahead and see if you can set that up on your own. Pause it if you need to. So we're going to take the larger function, which is the lobby, and we're going to say the area is equal to 2x squared, and we're going to subtract away the rug, which is 2x squared minus 18x plus 36. You should see that this is very similar to subtracting your functions, which is what we did before. Just make sure that you guys are putting this in parentheses. Always put your functions in parentheses. That way we show that we're distributing that negative, otherwise you're going to get a wrong answer. Alright, so if we go ahead and subtract, we get 2x squared. Everything in here becomes opposite, so we get negative 2x squared plus 18x and minus 36. Alright, we get that the area is equal to 2x squared minus 2x squared cancel. We get 18x minus 36. This is area, so this entire expression is in feet squared. And there's the area. So you actually end up with 3 areas. You end up with 2x squared, the area of your rug here, and then the area of the spot that is not covered by the rug. Alright. Here's your PPT, and we're going to go through this, but you may want to pause it depending on what Ms. Fitzharris wants you to do here. I'll let you guys read it on your own, so go ahead and read it, and then unpause it, and we'll go through what it means together. You get here that you are talking about 2 rectangles. One of them, the ratio of the height to the width is always 3 to 5. So if I draw my rectangle, this is comparing height to width. So the height is 3, so we're going to call that 3x. And the width is 5, so that's going to be 5x. If we find the area of this envelope, you'd have 3x times 5x, so we're finding the area of a rectangle, and that's equal to 15x squared. And this is in millimeters squared. Alright, the next part says that every envelope is made to be precisely 2 millimeters wider and 3 millimeters taller than its matching note card. So if we draw another rectangle slightly bigger, we want to match these up appropriately. So we find out that it's precisely 2 millimeters wider, and the width is represented with 5x here. So if it's 2 millimeters wider, it's actually 5x plus 2. It's 3 millimeters taller, and taller is the 3x, so it needs to be 3x plus 3. The plus 3 and the plus 2 have to go with those expressions. So if we find the area now of this, we see that the area is equal to 3x plus 3. That's our length times our width, or you can switch them around. multiply that through. I'm going to skip a step here, assuming that you guys can multiply because we've been practicing that. You end up with 15x squared. You get plus 21x plus 6 for the expression, and this is all in millimeters squared. Alright, and now if we go back to the problem, it does say that finally the amount of paper required to construct each envelope is equal to 3 times the area of the front envelope. So that actually means that we need to take this area that we just found and we need to multiply it by 3 because it's 3 times larger. So if we multiply this function by 3, we get 45x squared plus 63x plus 18. So the area is actually a little bit larger, well, a lot actually. Go back to the problem again. We have two things here we should point out. We have that this is the area of the envelope we started with. This is the area of the other envelope. Weird, I don't know why that put that through it. We're just going to leave that. And it says that the company needs to develop a function to calculate the amount of paper needed for each note card and matching envelope for any size or any possible size combination. So here's a possible 15x squared, and here's another possible. So if we want to find the total of these, we need to add these together. So let's go ahead and do that. So we have the first area is 15x squared. So I'm going to say my total area is equal to 15x squared, this function, plus the function that we just found, 45x squared, plus 63x plus 18. Adding these together, I'm really only combining two like terms here. I find out that my total area or materials needed is represented by 60x squared plus 63x plus 18, and remember that this is area, so put parentheses around it, millimeters squared. So kind of a long problem, but it had you do a lot of stuff here. It had you find two areas of rectangles. It had you multiply one of them by 3, and then it had you add them together. So a lot of operations all together. All right, I think we're just about done. All right, so your homework tonight is that you are going to be working on pages 83 and 84. You're going to do all of numbers 1 through 10. The first couple you should be able to go through quickly. You're going to be adding, you're going to be subtracting, you're going to be multiplying, dividing, and then I'm sure you're excited about this. You get to do word problems, which should help you practice for your test next Friday and what we covered the last couple of days. All right, so good luck. If you need to look back at this, feel free.